Hello and welcome to another episode of AWS Cloud Bytes. I'm your host Bhavesh Kumar. Today we have a lab around an architectural flow that you see on your screen. This is about an SNS topic publishing to an SQS queue and then going to a Lambda. The Lambda is processing messages from the queue, so basically a publisher and subscriber model. We will also see a DLQ. So the list of things that we are going to perform in this lab is given below. We are going to create an SNS topic. We are then going to create a dead letter queue. Then we are going to create a main queue that will refer DLQ as its dead letter queue. Then we are going to assign a listener to this SNS topic. This main queue will then listen to anything that is published on this SNS topic. We are then going to create a Lambda, update the Lambda role to add writing capability to CloudWatch or creating a CloudWatch stream and then listening to an SQS. Basically, any kind of message that is published on the SQS and is available to be consumed will be picked by the Lambda. Then we are going to create a Lambda listener that is going to basically be a listener to this queue. So this one is more about setting the roles. This one is more about assigning it as a listener. The subsequent things that we're going to perform is we're going to send message to the topic, which is the starting of this flow, and then this random message will succeed. We are then going to look into send another message to the same topic where the message is going to fail given the failure criteria that we are going to define in our Lambda code. And then I'm going to show you how the failure messages show up in main queue and in DLQ. We're going to talk about the redrive from DLQ to main queue. So how you can reprocess the same message that was failed earlier. Following this, I'm going to show you how to use the bulk messaging. So I'm going to use AWS CLI and push around 30 messages. We can push more, but I will just show 30 messages. These messages will be queued in a way that 15 will be destined to succeed and 15 will fail, given the logic that we have in our Lambda. Then I will show you again how these failure messages are showing up in queue and in DLQ. The last step will be to show you the receive count, how many times these messages were polled and received, and then how the receive count increases if we do it multiple times. Let's go into the lab. Okay, I have logged into the AWS console and I'm going to open service SNS as the first tab. You can either type SNS over here and I'm doing a control click, which is going to open another tab. Let me close all these tabs. So right now I don't have any topic. So let me create a topic. I would say test notification, and then this is going to be a standard topic, not the FIFO one. So it's a test notification. Display name, I can just say test notification and just create a topic. We are not going to do anything on that. So a new topic has been created. We are not going to publish a message on the topic right now. The next step in our lab is to create a SQS queue. So I will go and control click or command click in this case and create a queue. Now this queue is going to be a standard queue. What is a standard versus a FIFO queue? FIFO queue is where you want to have an order delivery. Standard queue will try to give you its a best effort, but the ordering is not guaranteed. But in case of FIFO, it is guaranteed. So let me make this as a test notification DLQ. I'm just giving DLQ as a suffix and I'm creating a standard. That's why there is no .FIFO as an extension. In case of FIFO, you have to have .FIFO over here for a FIFO queue. Okay, let's move on. So the visibility timeout is 30 seconds. I can show you what exactly it means. It means that if the message is picked, the message is not available to be picked by any other consumer of queue message until the timeout happens. So that's a visibility timeout, which means if a message has been pulled by a a Lambda and it is working on it for 30 seconds, no other Lambda is going to pull the same message. So it is not visible to other consumers of the same queue if you have multiple. Uh, we'll talk about the retention. Retention can be from 1 minute to 14 days. So your message can stay within the queue for 14 days if it is not processed. Delivery delay is primarily, I will click on that also. It is primarily telling you that how long do you want to delay even starting the processing of the message in the queue. It's not visibility, it's more about how much delay you want to add before your message is even picked by anyone, any of the consumer of the queue. Receive message wait time, it is required for enabling long polling. The range is from 0 to 20 seconds. The higher value reduces the empty responses and cost. It is like the consumer of or the queue processor, in this case the Lambda, is going to poll SQS for messages, and if there are no messages to be processed, then it is going to have the empty responses. So if it is going to get the empty responses, then in that case your Lambda is triggering and then the cost is going to be incurred on that, even if there is no messages to be processed. Let's look at the encryption. The encryption is enabled. It's a server-side encryption, and then we are using Amazon SQS rather than our own key. You can define your own key also, but you can just use the Amazon SQS, Amazon managed keys in this case. We'll just keep the access policy basic right now. Once we are done with this, then we're gonna update these. Redrive is disabled, and then this is again disabled because it is already a letter queue that we are making. And we are not going to create any tags, so I'm just going to create the queue. Now, if you look at the queues, we have one queue. Let me create the second queue. In this case, I will just make it test notification main queue. I'm just giving that name, no changes anywhere. And for dead letter queue, I'm going to just say use the queue that we created. So that's the dead letter queue. And maximum receives is like how many times I should be processing that message. So suppose you receive a message in the queue and then a Lambda picks it or any queue consumer picks it, processes it, fails, the message is still in the queue, it is not deleted. How many times you want that message to be processed by the consumer before you say that we cannot process that message, now it should be sent to a dead letter queue. So that is what this setting is, maybe a 3 times retries, and then we can create this queue. You can see that this is our access policy, and there is no SNS subscription, there is no Lambda trigger, nothing over here. The next step will be to configure the policy for the queue so that the queue can listen to an SNS topic. And also we are going to create a Lambda. Now the next step is to create a subscription. If you look at the topic, let's go to the SNS topic. This is our test notification, and there is no subscription over here. One way to do the subscription is to go over the queue, the main queue where we want to receive the messages that are published to the topic, and you can go and edit the access policy over here. So right now you can see it is only showing principal as a root and then all the actions on SQS main queue, which is this resource. And other way, if you're learning, it's better you understand how it works. So you can go and create a subscription where you can just say create subscription and the protocols. These are the protocols, basically different services that are allowed: email, email JSON, HTTP, HTTPS, all those. We just are interested in SQS. So we'll go to SQS. Now, when you select SQS, the main queue is the bottom one, and then you have this DLQ. We want to send any message that is published to the topic, the SNS topic, to go to this main queue. And we are not doing any kind of a subscription filter or redrive policy, because subscription filter might be like, I want to send only these kind of messages to this queue. And suppose there are messages around shipping and maybe invoicing, two different aspects of it. So depending upon what kind of object you're receiving, you can have different filter policies applied. Right now, I will keep it simple and just create a subscription. So you can see now, if I go back to test notification, you see one endpoint subscription is showing up. It is going to the main queue. And this is how the subscription is looking like. There is no filtering, there is no redrive policy attached to it. If you go back to the queue tab, and right now there is nothing for SNS because we haven't refreshed. If I refresh this, you will see that there is an additional statement that has been added. And you can see this is saying test notification. This is just an identifier, and it is telling which service is going to do this. And it is going to use the action send message in what resource you're going to receive this message and who is going to send this. So this is your test notification ARN. So that's all good. We have the main queue, we have the DLQ, we have the SNS. So if you look at the items that you are looking for, so you have done this, you have done this, these four things. Now we're going to create a Lambda and have the policies in place, and then have a listener to the main queue. So somebody is going to process. We can publish to the queue, but there is no processing happening right now because it is just sitting in the queue. There is no Lambda that is going to process. So I'm going to do the next step. Let's go to the console again, and then I will search for Lambda and open it into a new tab again. You have no lambdas right now. I'll create a function. We'll just give it a name, kind of a queue consumer. And the runtime will be Python. And we are not going to change anything, just create a lambda. So let it create a lambda. Now the lambda is created, there is no code, and you can see there is no attachments to this lambda. This lambda is, if you look at the configuration, this lambda is also not in a VPC. So let's go to the code. I already have a code. Let me paste that code, and I will do a walkthrough of that code. So it's a very simple code. This code is just saying that you will receive a event, and this event will have, like, you will have a record collection that you're going to receive. We are making a failure array because we want to return messages that have failed out of the batch that we are going to receive. By default, we'll have a batch size of 10 that I will show you how it is configured in SQS. For each record that you receive from SQS, all these messages that you receive, we are going to print the logger information saying what message has been received. This is like reading the body and message ID. Now, if the body has something called fail, which we want to simulate for the failure, it will raise an error, which will be caught in an exception, and then that will be appended to the failure array that we have. And at the bottom, you can see it returns the batch response. So anything that has failed will be returned to the queue as a response of this Lambda processing. This will be returned. And given these response of failures, queue is not going to delete those messages. The messages that are successful in this particular processing will be removed from the queue. Rest of the messages that failed will be reprocessed until the max receive that we have set as 3, which means it will be processed 3 times at least before it is sent to the DLQ in SQS. So let me deploy this once you have that. Okay, the code has been deployed. Now let's go and do the next step, which is going to the configuration. And we need to go to the permissions. So you have general configuration, triggers. Right now there is no trigger. And you can see it over here also. You don't see any SQS trigger over there. Now, if I go to permission, this is the role that was created. I'll open this role in a new tab. Now, if you look at the policy, this is what we have. We can create a log group, create a log stream, put log, all those sort of things I can do. But we need to modify this. So I'll open this. You can edit this policy using the visual editor or in JSON. This is how it looks in visual editor. In JSON, I will go and just add a new statement. And now we need SQS because we need to push it to SQS. And what all things do we need? We need to get the queue attributes. We need the receive message count, which is this one. We need to delete the message from the queue and the change visibility. Those are the 4 things at least required. And once you're done with that, we can say next. Oh, sorry, I missed on adding the resource. So resources, which resource? I will just put the ARN of the main queue, which is, let me go to the SQS main queue, copy the ARN from here, go back to the policy edit and paste it over here. This is the resource on which we want to apply. So you have the EAR in place. So effect, the actions are these, and on what resource we want those. So the next will show you the changes, and then we can save it. Now your role has been updated because your policy that is attached to the role has more information. It has more capability. Now it can do read and write on this queue as well as logs. So it can create a log, it can create a log group and stream the log, and then all these events that can be written to the log. Let's go to the queue consumer again. Now we have updated the role, not changing anything on the role, but basically applied a policy. Let me refresh this. So you can see there are 3 actions and 2 resources showing up. If I open this, you can see SQS and your CloudWatch logs. So total 7 actions are there and 3 resources. So if you go to the trigger and add a trigger, you need to choose SQS. We are going to poll the queue, which means it is going to listen by calling the queue and trying to say, oh, if you have message, give me those messages. We are going to activate this trigger. Now this is where you tell how many messages do you want to receive in one go. You can start with the default, which is 10 in our case. We'll just keep 10, but you can have bigger because Lambda runs for 15 minutes. And if you need more, you can actually have more for standard queues. For FIFO queues, it is 10. And I think that's all we have in this. We are not going to add any other filter criteria or tags. So I'll just add this. Now you can see the diagram has changed a bit. You can see an SQS and you can see a queue consumer. Now the queue consumer is polling SQS. Do you have any message for me? Now let's go to the queue and I will refresh the queue. And you can see there is a SNS subscription that we created earlier, that it is listening to anything that is published on the SNS, and then there is a Lambda trigger that we just created. which means anytime there is a message in the queue, this Lambda is going to trigger, and the Lambda is going to pull the messages out of the queue and process it. If you go to the monitoring, you will find that you have number of messages that are not visible, number of messages that are delayed, oldest messages, empty receives, all those sort of metrics. These empty receives are like the Lambda is calling, but there are no messages. The trigger is enabled, which means Lambda will be calling SQS to find if they have any kind of message in the queue. As a next step, let's go to the SNS topic. Let's publish a message. I will say hello world, and then there is no group ID that I'm going to give, and this is a test message. And over here I can have some kind of structured key value pair, so maybe an order ID 1234, and I'm going to publish this. Now that message has been published. If I click on this, maybe it is already processed. Let's look at the CloudWatch log, because CloudWatch log is going to give you some insight. So you can see there is a log stream here, and you can see that a message was received. As soon as I published, it was picked by the Lambda, and that's why you can't see that in the queue. So you can see the subject was hello world, and this is a test message that was in the body. And then I added some attributes like order ID was a string type of 1234. And you can see that this has been successfully processed. That's why there are no errors. So let me go back to the publishing again. I'll publish another message. And this is hello world failed. And we are simulating a failure over here. And then our code says if you have fail to deliver this message. If you have fail in the body, it should fail. Adding another order ID string, maybe 2222 in this case, and we'll publish this. Now, if I go to the queues, we'll come to this. Let's go to the CloudWatch first. And you can see that the message was received. Hello world failed to deliver. And then there was error in processing the message. This is basically saying simulated processing failure for testing DLQ. Okay guys, I just found a small issue in our setup. The way we are processing it is like we are sending a batch and we are reporting a batch error. If you look at the key, this Lambda that is performing all these operations, we are sending a failure batch. But one thing that we missed while doing the configuration is that the reporting of batch failure is no. That's why the queue is not receiving it. So let me edit this. We go to this and we have to select this one, saying that you need to report the batch failure, whatever failed in the batch. Once this is done, if I run, publish another message saying this is a failed message, and in the body we are expecting fail to deliver message, and you can put anything over here. Order ID, I will just say order ID 123456 and publish the message. Now you should be able to see all this because the queue consumer is going to process it. Let me go back to the logs. There's a new log. We are sending it as a failure. Let's see. It should re-trigger sooner. You can see the message was in flight over here, which means there is a retry that happened. And it should show you error processing very soon. Okay, you see now too. So this was the initial receive failed message, and the order ID 123456. We sent it as a failure. Now the failed message was received again, and then we sent it as a failure again. Let's wait for another minute. So the message is again in the flight. You will see there is another processing that happened. The queue message was again processed, and because of the body, it was again failed, a simulated failure. If you go to the queue back, you can see that message is now in the DLQ. The main queue has stopped processing. So if I go to the DLQ and if I go to send and receive and perform a poll for message, you can see the message that failed is available here. This is what we sent as a subject, and this was the body, and this was an additional attribute that we added, order ID 123456. Now if I have to reprocess, suppose there was an issue that Lambda was not processing it properly, and now the Lambda is up and running with the right set of code. If I want to reprocess, I will just select the message, and then I'll go over here to either delete. That is one way you can get rid of this message, and then you can send another message. Or you can go to the main page of this DLQ, where you have this button called Start DLQ Redrive. And then in the Redrive, you can see how many messages are there. Redrive to the source queue now, and just click on the Redrive. So what we can see now is the message is again in the flight, which means the queue is going to reprocess those messages. You can see another execution which failed, and it will wait for next execution. As soon as you get the next execution, you will get another log. So I'm just waiting for it to execute the message again. You can see there is another log that came up. So we reprocessed it, and then it was failed again. And once it is done reprocessing 3 times based on our receive count, it will send this message again to the DLQ. So this was the last execution that happened. And once this execution is done, message is still in flight. You can see the message went again to the DLQ. Now we have already done a redrive on this. So rather than sending this message again, I will just go and delete the message. That's the overall flow. Now we have seen that how main queue can process it multiple times depending upon your receive times that you have defined. And then if it is sent to the DLQ, how the DLQ is going to process it. If you redrive, it will go to the main queue, the source queue for the DLQ, and then it will again process it. And if it fails again, it will again send it to the DLQ. Now in the DLQ, we just deleted the message, so there are no messages. As part of the next step in the lab, we are going to push a lot of messages to SNS using the AWS CLI. So this is a small script. It runs from 1 to 30, and it is using AWS CLI. You can see the publish over here, and then this is taking the topic URL. This is our SNS topic. Then in the else condition, We're just saying 15 out of these 30 are going to be fail messages, and then rest of the 15 are going to be success. So this is again pushing to the same topic, but with a pass message. Let me click on this. You can see it is just queuing all these messages. Once it is done, I will show you how it is looking on the queue. So we got all 30 messages, and if I go to the queue and refresh it, you'll see there are 15 in flight. We'll go to the CloudWatch logs, and you can see that there are a lot of processing of messages that has happened. This was received. This is a pass. Then we can refresh this and see what is happening. So you can still see that 15 are in flight. The 15 that were pass would have been removed, but we'll see. Let's wait for these 15 to be processed 3 times and then move to the DLQ. You can just see how it is processing it multiple times. I will just enable the auto retry. You can see it is processing. So in one time, if you look at how the Lambda works, if I go to the monitoring side of it, you can see the error count and how long it has been running. All those sort of metrics are there. So these are the receives that it is getting. Error and success count. The concurrent execution is 1. We haven't defined multiple lambda, so there is no concurrency that we defined. So a single lambda is processing, and we are processing 10 messages at a time, which is visible if you look at the triggers. We are saying at a given point of time, we are going to pick 10 messages. So it is processing 10 messages in one shot. Every time it picks, it processes 10 messages, and you can see it is growing. Now, if I go to this, you can see that it has already done 3 retries on these messages. So the receive count has been 3, and then because it was not able to process these 15 messages out of 30 messages, these are now available on the DLQ. So if you go to the DLQ and you say send and receive, and let me increase the poll setting to say 20, and poll for message, you will see all those messages that we sent are here. You can see failed message 20. If you look at the script, again, it was with an identifier over here. So the loop number is here, pass and fail. So you can see that this is number 20. We can open another one. This is 12. This is 30. And maybe this is 18. All those messages are here. Now, if I have to retry, I can actually go back to this and say start DLQ redrive, and then the source queue is already set, so we don't have to set the source queue. But if you want to send it to a different queue altogether, you can do that. But right now it is already a source queue, so I can actually do a redrive, but it is going to fail again. So it's better I will go perform a send and receive over here and delete these messages. So that's all about the overall flow of how you can have messages published. And SNS is just one way to publish that. You can send it to the queue, but you can use your own custom code to publish these messages using the AWS SDK to the queue. And then from the queue, this is the consumer of the queue, which can just listen. You can increase the concurrency of the consumer. So if you have a large number of messages coming into the queue, you can always go and process it at your pace. So that is the end of the lab. I hope this was helpful. So that is the end of the lab. Hope this was helpful. Please let me know if you have any questions. I will try to answer them. I will post all this information, all the code as well as the batch to just queue a lot of messages to the SNS topic. I will add those into a Git repo and you will find that in the description of the video. Thank you for watching. Please like, share and subscribe. Thank you.